Okay, question 4. I think I will skip through A, but what I'll do is I'll talk you through what is important about it. This is the kind of what we can say an essay-based understanding. Okay, do you have an idea of what you need to write before you start writing? Well, you should have an idea of what is meant by fermentation. Okay, so you do need yeast. What kind of condition does the yeast work under? So you need to specify the conditions. All right, so yeast is like a biological catalyst in this case. It doesn't work well at just any random temperature. You need to think about the temperature. Okay, so the temperature especially. Okay, and then you also need to think about ethanol. So manufacture of ethanol by fermentation. So what is it? Okay, best thing is write balanced equation. Any equation you write has to be balanced, and I can tell you the equation is basically you start from sugar, right, which is glucose, C6H12O6. It will give you CH3 CH2OH. It'll give you 2 of it, and it'll give you CO2 and 2 of it. Okay, so I proceed by that, and this one is going to be a solid. You actually need a bit of water to dissolve the yeast and to make the reaction go faster. Any reaction just involving solid is not going to be fast enough, right? So you actually need a moist condition. You need a bit of water as well. Okay, so you will have water mixed in with the alcohol, which means you need to separate out eventually. So you need to talk about the separation of CH3 CH2OH from water, which you use in your reaction, because otherwise the reaction just involving solid is going to be much slower than when you dissolve in water, right? How are you going to do that? Well, you know they have different boiling point, so you can talk about distillation. Okay, so that's the kind of idea that you need to separate after you do it in the presence of yeast and in whatever condition it is, and any equation you write, you have to balance it. All right, so I hope that makes sense there. Ethanol can be oxidized by oxygen to form ethanoic acid. So they give you the display formula where they show every single covalent bond, including the OH, which is a covalent bond. Okay, so you can write the formula like CH3 CH2OH. Okay, I mean that is what I would do. It can be oxidized by oxygen, so by oxygen like that, and then it gives you CH3 CO2H. Alright, so oxygen exists as a diatomic molecule, right? I hope you can see the CH3 and the CH3 balance, so we don't need to look and concern ourselves with the CH3. We need to, however, look at CH2OH and the CO2H. There is one carbon, there's one carbon, okay? I mean, you don't need to worry about CH3 because they balance already, yeah? The carbon and the carbon balance. The hydrogen, there are 2 plus 1, there's 3, and there's only 1 hydrogen, okay? I actually need water as well. Okay, so they don't tell you that, but there's the other 2 hydrogen. Now you have 2 plus 1 3, 1 plus 2 3. Okay, now the oxygen here, there's 1. Here is what I need to balance. I'll leave that until later, so I work out whatever oxygen is here first, because the hydrogen already balanced. There are 2 oxygen, there's another oxygen, so there's 3 oxygen. 3 minus 1, there's 2, so there must be 2 oxygen here. But this is already O2, so that means I only need 1, which means it's already balanced. Okay, so I hope that makes sense there. The reason why I write them in this form rather than using molecular formula where I have C2H6O is that I can see exactly the CH3 is balanced and I can see them easier. There is nothing wrong with writing like this based on CH3 CH2OH, or if you only can write in molecular formula, it's perfectly fine as long as you could balance it, yeah? Now you have ethanol and ethanoic acid. You need to show all the atoms and all of the bond in this product. Okay, I can tell you that is acting as a catalyst. I hope you can see that ethanol and ethanoic acid in the presence of this as a catalyst is what you call a condensation reaction. So the name of the reaction is called condensation because what are you forming? You are forming ester. You have alcohol and you have ethanoic acid. Okay, you have a 2 carbon alcohol, very important. You have a 2 carbon acid, if, okay, 2 carbon. All right, so you want to show everything. I guess it's easier if I show the ester first because I know it forms ester. Ester, right? C double bond or carbon form 4 bond, 1 2 3 4. Okay, the oxygen form 2 bond, 1, 2. The oxygen form 2 bond, 1, 2. But it's not a polymer like that. I need to show the product. Okay, there are 2 carbon. I'll show this first. This bit is the new bond that you are forming. This is the all bond of the ethanoic acid. Ethanoic acid means there are 2 carbon, including this one. So there's 1 carbon. There's only 1 other carbon, because 1 plus another 1 will give you 2. Carbon form 4 bond, so it's just filling it with CH3. Okay. Now the alcohol bit is the one on the right hand side here. This is the bond that you break, so they will get OH. So that means this is going to have 2 carbon. So 2 carbon. And then carbon form 4 bond, carbon form 4 bonds, 4 covalent bond. Okay. I'm going to erase this bond which show breaking because I don't want to break it here. I want to form it, the product which is an ester. Okay. You want the equation for fermentation of glucose. So what happened in glucose fermentation is, actually, I think I got the concept of tapai wrong here. So this is not the chemistry of tapai here. Okay, this fermentation of glucose is the one that involved the fermentation of tapai. So tapai is a Malay food, and unless you're familiar with it, you will know what I'm talking about. So just ignore me there. So glucose is C6H12O6. When they get fermented in the presence of bacteria, you get C2H5OH, you get ethanol, and you also get carbon dioxide out of it. So what happened then is you need to balance the equation, and all the hydrogen goes here. There's no hydrogen there. So because there are 12 hydrogen here, and there's 5 and 6 hydrogen, so I know I will need 2, because 5 and 1 give you 6, so 6 times 2 give you 12 hydrogen. So now my carbon is carbon 4, I need carbon 6, so I need 2 CO2. Then I check the oxygen, 2 oxygen, 2 times 2 is 4, so 6 oxygen. This equation is balanced. Alright, so now I want you to know the conditions. So the condition is basically you need a yeast, which is your, that's the one that makes the reaction goes, and you need water. You need to do it in the presence of water as well, and it will really help to drive the reaction. And then you can also think about warm enough temperature, but not too cold and not too warm, because you're dealing with yeast here. So somewhere around optimum temperature, around 20 to 40 degrees Celsius. So not too cold, not too warm. Okay. And how many do they want? They want 2, so I guess just choose 2 out of the 3 really.